In this introductory module, we will explore how thermodynamics approaches chemical transformations. In this course, I aim to structure the content step by step, introducing each new concept one at a time without mixing topics prematurely. This approach differs from some other sources where, for example, the concept of chemical potential is introduced without sufficient background. While the chemical potential is often discussed in the context of chemical reactions, it has a broader scope beyond just transformation of chemical substances. You will discover the versatility of the concept of chemical potential later. Now, when we move to the thermodynamic description of pure substances, you will notice that the thermodynamic treatment of chemical reactions and pure substances are closely interconnected. This is why the title of this unit includes both pure substances and chemical equilibrium. In chemical thermodynamics, we adopt a simplified perspective when it comes to chemical transformations. While every chemical reaction is in reality a complex multi-step process involving various intermediates and mechanisms, we don't concern ourselves with these details. Instead, in chemical thermodynamics, we view a reaction as nothing more than a change in state. We are only concerned with the initial and the final state of the system. The initial state consists of the reactants, and the final state consists of the products. What happens in between, meaning how the reactants transform into products, does not influence our thermodynamic analysis. The reaction can be seen as a black box, a concept borrowed from systems theory and cybernetics. We don't look inside the box to examine the detailed steps of how the transformation happens. Instead, we are only concerned with what goes in, the reactants, and what comes out, the products. The inner workings of the black box, the exact path of the reaction, is irrelevant to thermodynamics. What matters is the fact that a change in state has occurred. Once we recognize that a chemical transformation is just a state change, we can focus on the corresponding changes in state functions, such as U, H, S, G, and so on, between the initial and final states to understand and predict how the system behaves. The reaction itself remains a black box, and our attention is entirely on these measurable and calculable state changes. This approach will serve as our starting point in this unit, where we will explore how thermodynamic principles are applied to chemical reactions by analyzing these changes in state functions.